In this video, we are going to consider how to find outliers by hand calculations using quartiles, thereby showing the significance of quartiles in everyday statistical uh, discussions. Now, you see, one of the key graphical tools that can be very useful in finding outliers is a box plot. The point I want to make here is that besides histograms, we can use other what types of visualizations for finding or examining the distribution of numerical variables. And to draw a box plot, which is an alternative graphical representation of the distribution of a numerical variable, we need a 5-number summary. 1, the minimum value is the first of the 5-number summary. 2, 3, 4, 5. The second one is the first quartile. The third one is the median. The fourth is the third quartile. And the fifth is the maximum value. So, if we are required to make a box plot of the following data, how can we do that? Well, we're going to need to use StatCrunch to do this. So we can go back to StatCrunch. I'm going to close out of this, and I'm going to look at the data, and I would like to graph a box plot. So I'll go to box plot under graph, and box plot of what variable? That'll be outlier data. So I'm going to choose outlier data, and I want to use fences to what? To identify outliers. I like to draw the box horizontally. You will soon see what that means. And then I also like to look at the median in particular. So I am going to drag this up a little bit so that I can see the compute button, and I'm going to do that. Okay, let me see. There we go. Good. So here are a couple of things to note. If I move my cursor here, I have a lower limit of 1, and then I also have an upper limit of what, 11.5 in this case, and then the median is 7, and the third quartile is our 9, and then this is the first quartile, which is 1, which is 2 rather. So in this case, I have used the first quartile, which is 1, and then the third quartile, which is 9. Those are the upper and lower ends of the box. And then you have the whiskers here, right here, and here. And what I can immediately tell is that this, box plot tells me that there's a bigger concentration of data values here, in this case, than here. So this seems to be slightly left skewed. If you have more values here, you have those values here, and you have a longer tail to the right, which means there are fewer here. So I meant to say that that looks more like something that has that this. So you have more bumps here. So this will be right skewed there, so to say. All right. So with that said, let's look at another case where we compare the picture of graph represented using histograms versus what? Box plots. Now, considering these histograms, we would like to match them to the box plots that represent it. I can see that in this case that the center here is centered around 60. So I'm finding which of these boxes has a median at about what? 60. From what I can see, that would be the second one. And so that means that I'll match histogram A to number 2. And then histogram B is centered around 50. So that will be 3. And then finally, this is centered, you see more of the bump around 1. So that will be this guy right here. So I can tell that from the combination that in these cases, for instance, the histogram A is symmetric, it is unimodal, but I might not be able to see the outliers very well. Or if I use a box plot, I'll be able to see the outliers very well. And I can see these dots, these are outliers. So box plots shine in being able to quickly highlight if you have outlier data in your data set. Histograms not so much, but histograms shine in showing you the shape and the center of that distribution. So I can say that A in this case has a symmetric unimodal and with what? Some outliers. Whereas for B, I can say this is a uniform distribution. And since it is uniform, it is also symmetric. And does it have outliers? Let's go to the box plot. No outliers. And then for C, this is definitely right skewed. It's a right skewed distribution with one mode, unimodal, one peak, and then many outliers. Then let us see another example. Again, still comparing box plots to histogram. The only relevance here that I want to show is that with histograms, you are able to see both the shape and then the center, but this might present a little challenge to judge if it is an outlier or not. But by the time you come to the box plot, once you see these dots, this confirms what? The presence of outliers. So histograms are very good in shining the shape and center characteristics of the distributions of numerical data, whereas box plots are very good in showing whether outliers are present or not.